Welcome back to the Henstitute. I just want to make a quick extra little comment about work. So we know that work is equal to the force multiplied by the displacement. And then times, so these two quantities, and then multiplied by the cosine of the angle between those two. So this is theta is between your force direction and your displacement direction. And I'm going to just use D with an arrow over the top to represent my displacement. So our equation looks like this, that work equals F D. I'll just use D for a displacement. This could be vertical displacement, it could be a horizontal, it could be a diagonal, whatever. And then our little cosine theta. So this is our equation for work. So what it did is over here, I have a person doing bench presses. So when they push up on it, they are moving it a displacement in the vertical direction. So this would be their displacement vector. So in this particular case, they would actually be doing positive work. So we would take whatever the magnitude of the force is and whatever the magnitude of the displacement, we would multiply those two. And since they're in the same direction, we would just have to multiply by the cosine of 0 degrees. So don't worry about the fact that they're moving it vertically. It's not 90, so it's not in comparison to a horizontal axis. It's just comparison between F and D. And since they're both in the same direction, that's positive. Our angle here would be 0 degrees, and the cosine of 0 degrees is 1. So we'd have positive work. In this second case, however, we have our force is still acting upward. So when you bring that bench back down, when you bring that bar back down, you still have to apply an upward force. You don't have to pull it back down. Gravity's doing that for you. But in this particular case, your displacement would actually be in the downward direction. And so here we would actually have negative work because our angle is going to be 180 degrees. Now, if they happen to push kind of diagonally, let's say that when he was actually doing his bench press, he kind of pushed diagonally like this for some reason. I don't know why. Maybe he's not able to push it up quite straight or whatever. But by pushing it kind of diagonally, now what we would do is we would actually have to take the angle between those two. So if I were to take that situation, and I'm going to make this pink so we can kind of see what's going on here. Here I would have a force that's acting this direction, but my displacement is acting in this direction. So the angle I would take would be this angle right here. And so what we would find is we would have some angle that would be a little bit greater than 0 degrees, but it would still be less than 90 degrees. And so we would have a cosine of theta that would be some number that would actually be less than 1. And because of that, he would actually be doing slightly less work than if he benched it straight up. So actually doing that diagonal actually helps him a little bit. Now, the last thing I wanted to kind of talk about today, because it doesn't take a whole lot of time, is the idea of power. Now, we have talked about power in our electricity chapter, and it was equal to the voltage multiplied by the current, or it was energy over time. But the basic definition of power is actually the amount of work you do divided by time. In other words, it's the rate at which you do work. So our equation of power, which is going to be measured in watts, would actually be our work divided by time. So this would be our joules divided by seconds. And we saw this with our recent test, because what we did is we could multiply the watts times the seconds to get joules, or we could take our kilowatts and multiply by hours and get kilowatt hours, which is another unit for work, another unit for energy. But a couple of extra little things here. If we actually replace work with the equation for it, that it's force times displacement times the cosine of theta, all divided by our time, one of the things we notice is we end up with a little d over t. This is really just the average velocity of the object. So another way we can actually find power is we can take the force times the velocity of the object, where this would be the average velocity, multiplied by the cosine of the angle between those two. So this is another way to find power. Now, we're going to go back. Little v here is now going to be velocity. So now we're back into our old chapter, our mechanics. So we're going to be dealing with velocities and not voltages. So we've got two different ways to kind of look at power. We will see how that relates with energy. Why did we use energy when we were talking about electricity? We'll get back to it. And we also have a little bit up here where we talked about work, just as a reminder that we could have work happening when our angle is somewhere in here. And we can have negative work. Yes, work can be negative. What that actually means is that you are, what we're going to find out is how that is related to energy, how we are changing the energy of an object. This has been the Henstitute. I hope you're having a great day and a great week.